All right, welcome everybody. In this video, I want to describe a mathematical method called the bisection method, which is used to find zeros of continuous functions. So I want to explain how that process works in general before we try and code up that in R. So let's consider some function f. Let's say it's this function that's drawn over here in blue. So this is a continuous function. This method does not apply for functions that have jumps or discontinuities in them. But we're going to assume we have a continuous function f. And in this case, this function happens to have 3 zeros that I've marked in red. So let's say I want to track down this 0 right here. Then what I can do is pick a value of x, say a, where the function is positive. I can pick a value of x, say at b, where the function is negative. And if this function is continuous, if we have that assumption, then there's no way that I can join a point above the x-axis with a point below the x-axis in a continuous fashion without crossing over the x-axis, so without having a 0 in between them. So if I find a x value a where the function is positive and x value b where the function is negative, then I know that if the function is continuous, somewhere between them is a 0. Or vice versa. I could start with a value on one side which is negative, a value on the other side which is positive, and I still know somewhere between those two sits a 0. So how this bisection method works is I start with two values of x, one that have opposite signs when I evaluate f. So f of a might be positive and f of b is negative. Then I want to track down the 0 that's between them. So my first guess is, well, maybe that 0 is located right at the midpoint between those 2 points. So that's what this value m is noting. I haven't necessarily drawn this to scale, but let's say m is the midpoint between a and b. So then I check the value of the function at m. And if the value of the function at m is 0, then we're done, right? Or if it's close enough to 0, we can exit our loop that we're going to set up. If the value of m is not that close to 0, okay, it's either positive or it's negative. If the value of at f of m is negative, then I would choose the other endpoint to be a or b, ensuring that the value of f has the opposite sign. So in this case, I found m. M, when I evaluate f, gives me a negative value. So I'm going to replace the endpoint b, which was where f was negative. Now I'm going to use a new endpoint over here, which is going to be m. So now I'm going to repeat this process using a as one endpoint and this new value as my second endpoint. There could be some situations where like the midpoint wound up over here, in which case I'm not going to use a and m as the endpoints, but in that case, I would replace the endpoint a with my new midpoint value m. So I would use that as the left endpoint, and I would use b as the right endpoint. So depending on what the value of f is at this midpoint, we then adjust our endpoints so that we have a positive one and a negative one, but they should be closer to the 0 that we're trying to find. So each time I run this iteration, I'm going to be getting endpoints on each side of this 0, and it's going to be getting closer and closer and closer, and eventually it's going to hone right in on that 0. So that's how the bisection method works. Let me clear out my drawing here. So just to kind of reiterate that, what we're going to do is we start with 2 points to a and b, where the function f has different signs. So the way that we can check that mathematically is if the product of f of a and f of b is negative, then we know f of a and f of b have opposite signs. So once I've verified that I've got 2 points that have where the function f has opposite signs, well, then there should be a 0 in between those 2 points, assuming f is continuous. So let's just approximate that 0 to be the midpoint between them, m, which is equal to a plus b divided by 2. And then we check to see if m is within our level of precision. If f of m is close enough to 0, we can stop. If otherwise, if f of m is not really close to 0, then I check to see if m gives me a value of f which is the same as a, the same sign as a. So if f of m times f of a is negative, then I know that they have opposite signs, that f has opposite sign when I evaluate it at m and a. So now I'm going to set my new value for b is going to be this midpoint m. And I repeat this process. If f of m times f of a is positive, then I know that m and a, the function f has the same sign at both of those values. So I don't want to replace b with m. Instead, I get rid of endpoint a, and I'm going to set endpoint a equal to m now, and I still use the other endpoint for b. So that's how the bisection method works in general. In the next video, we'll set up a while loop to perform that method.